Hi, everybody. In this video, I'm going to go through lesson 3.1, inductive ver versus deductive reasoning. So we are going to begin Unit 3 talking about proofs and arguments. The first thing I want to discuss is what is a conjecture. A conjecture is essentially an educated guess. Or a theorem. That has yet to be proven. Your educated guess or your theorem that is yet to be proven, that is your conjecture. So how do we prove a conjecture? Well, we use different types of reasoning. And before we even get into that, I should note conjectures can be proven true or false. So if you are proving that a conjecture is true, you have to prove it's true for all cases or for all scenarios, whatever this conjecture is. And if you are proving that it is false, you can prove false with one counterexample. The counterexample disproves your statement. So a counterexample is a specific example that shows a statement is not always true. Kind of changing the order I made my notes originally. I'm not going to abbreviate. Shows conjecture is not always true. So if we're going to prove something's true, we're going to prove it's true for all cases. And if we're going to prove that something is false, we only need to provide one counter example, which is a specific example showing that conjecture is not always true. So let's talk about our basic types of reasoning. So our basic types of reasonings, there are two main types. We have inductive reasoning and deductive reasoning. So inductive reasoning uses general observation to create a general rule. This general rule is like a pattern. If I have the sequence 2, 4, 8, 16, 32, and so on, we could find the next number in this pattern by observing what happened earlier on. So we had 2 and then 4. So it looks like we either added 2 or even multiplied. And then to get from 4 to 8, oh, it looks like we are multiplying by 2 here. To get from 8 to 16, you'd multiply by 2 again. So we're multiplying by 2 to get to the next term in my pattern using inductive reasoning. I'm going to multiply 32 times 2, which is 64. You also can use inductive reasoning with visuals. So maybe I have a singular dot, and then I have 2 dots with 1 on top. So notice that now I kind of have 2 dots across the bottom, but then I also have diagonals of 2 dots. And then I'm going to increase it to 3. And we could find the next shape or the next formation increasing this pattern. So this was 1 dot, and then we increased it to 2. And remember, we had those kind of diagonals. And then 3. You also could look at it as the bottom row has 2, and then the row above it has 1 less. So this top row has 2 minus 1 or 1. The bottom row has 3. The row above it has 1 less than 3, which is 2. And the row above that has 1 less, which is 1. So to find the next shape in the pattern, I'm going to have 4 dots as my base. The next row is going to have 3. The next row will have 2. And the last row will have 1. Just continuing this pattern. All right, so that's inductive reasoning. Let's talk about deductive reasoning. And deductive reasoning uses previously proven, oh, I don't like it, proven or accepted properties. So if you have any known properties, any theorems that we know, and a theorem, that's a statement that can be proven true. So for example, I know the definition of a quadrilateral, right? Quadrilaterals have 4 sides. Oops. And they have 4 angles too. Let's include that. So with this definition, then I could reason that a square has 4 angles and 4 sides, or 4 sides and 4 angles. So a square then has to be a quadrilateral. If I know the price of apples is $1 per pound, and I'm gonna go buy 5 pounds of apples, I'm gonna make a conjecture that I will pay $5 for apples because I'm purchasing 5 pounds at $1 each. So when we use those previously proven or accepted properties or anything that's given to us, anything we know, that's using deductive reasoning. So in general, you're going to start with some conjecture or some theorem which really just is a statement to prove. From there, you are going to make your argument. And you are going to do this using known statements. Use this color. So using, I'm going to say known facts or patterns. And these are called premises. So when you go through and you complete the steps of your argument, you are using these premises. You also could be making your counterexample here. So if you're trying to prove something false, this is where you would make your counterexample. And the final step is you arrive at your conclusion or your final result. Is the theorem true or the conjecture true? Is it false? All right. Let's look at some examples. Example 1, we are going to observe the following pattern. So we are going to have kind of a set of squares, and each one is going to be checkered. So there are 5 of them in total. 2, 3. Does not have to be amazing. You just need to get the gist. 4, 5. And then we're going to fill them in. So the first one has this square filled in. The second one has this square. The third has this one. And the fourth has this one. And our fifth square is back up here. And then we want to find, or we want to form, actually, we're going to form a conjecture for the next shape in the pattern. So looking at our pattern, if I wanted to describe what's happening here, it looks almost like this is rotating, right? It's turning clockwise. So my pattern, it's rotating clockwise. You could almost even think of it as your square is jumping, right? It's moving. First it moves to the left, then it moves down, then it moves. Oops, I get my left and rights mixed up every now and then, especially when I'm making a video. First it moves to the right, then it moves down, then it moves to the left, then it's going to move up. Now we're going to move back over to the right. So the next shape is still going to be this square, this grid. It's 2 by 2 grid. But the colored in square is going to be this upper right-hand corner. It's rotated once more. So this is our next shape. Okay. Example 2. Given that angle A is congruent to angle B, Ash conjectured that angle A and angle B are acute angles. And I want to pause real quick and go back up to the top, or not the top, but the last example. And I just want to say, because we were observing this pattern, this is inductive reasoning here. Let me just make that note. All right, example 2. Sorry, back to example 2. Given that angle A is congruent to angle B, Ash conjectured that angle A and angle B are acute angles. This statement is false. Sorry, Ash. This statement is false. Find a counterexample. So let's disprove Ash by finding a counterexample to this conjecture. So our conjecture, our claim, is that A and B are acute angles. Given that angle A is congruent to angle B. So we know, or it's given, that angle A is congruent to angle B, which really means the measure of these two angles has to be the same. The measure of angle A is equal to the measure of angle B. And Ash is conjecturing that angle A and angle B have to be acute angles. So if we were going to come up with a counterexample would need two angles that are congruent, but angle A and angle B are not acute. So we want an angle A that is congruent to angle B, but A and B are not acute, meaning they are right angles, they are obtuse angles, they are straight angles, they are not acute angles. So perhaps I let the measure of angle A be anything that's not an acute angle, so anything that is greater than or equal to 90 degrees. So maybe I let measure of angle A be 100 degrees, and I let the measure of angle B be 100 degrees. So that angle A and angle B are congruent. So this means the measure of angle A is equal to the measure of angle B, or they are congruent angles. But angle A and angle B are both obtuse angles. Angle A is obtuse, and angle B is obtuse, which really means they are not acute angles. So this is a counterexample. If the measure of angle A is 100 degrees and the measure of angle B is 100 degrees. All right. Please let me know what questions you have on this section. This is really a lesson that you need to practice. I'm going to make the lesson 3.2 video very soon as well. And once you have both of those lessons down and you've been practicing, definitely try that quiz.